we will start with the next set of problems, okay, which involves half angle, double angle, triple angle, multiple angle, okay. So exercise 13A, question number 5, sub question 3, integration of cos square x minus sin square x upon root of 1 plus cos 4x dx. Now 1 plus cos 2x. Okay, 1 plus cos 2x is 2 cos square x. Therefore, 1 plus cos 4x will be 2 cos square 2x as per the half angle formula. Also, at the same time, this thing is also cos 2x. This is the formula for cos 2x, if you remember. So, integration of, in the numerator, it is cos 2x in the denominator root of 2 cos square 2x. Okay. Now there is multiplication over here. So that root 2 will be separated with the root of cos square 2x. Okay. So r is equal to 1 upon root 2 cos 2x root of cos square 2x. Since it is multiplication, I separated the roots. Okay. So this is 1 by root 2 cos 2x upon cos 2x dx. The square and the root will get cancelled over here in the denominator. This is 1 and integration of 1 is x plus c. Okay. Fine. Next one. Uh, Next question. Just a second. Exercise 13. Question number 5. Sub question 5. Integration of 7 cos cube x plus 8 sin cube x upon 3 sin square x cos square x dx. Now split 7 cos cube x 3 sin square x just a second. 3 sin square x cos square x plus 8 sin cube x upon 3 sin square x cos square x. So I've just split this into two parts. Okay. So you can proceed. I'll just wait for 2 minutes. First step was to split. Now some cancellations. Okay. So cos cube and cos square is getting cancelled. So there is only one cos left. Sin cube and sin square is getting cancelled. Only one sin left in the numerator. So this is equal to 7 by 3 cos x upon sin square x. Now this sin square x can be written as sin x into sin x. Have we done this earlier? 8 by 3 sin x upon cos x into cos x. Okay. So whenever it is sin upon cos square or cos upon sin square, you have to write the denominator two times. Sin square is expressed as sin x into sin x. Now this is cot x and this is cosec x. This is tan x and this is sec x. Okay. So 7 by 3 cot x into cosec x plus 8 by 3 tan x into sec x dx. Now these are individual formulae. 7 by 3 outside. Integration of cosec x cot x is minus cosec x plus 8 by 3. Integration of sec x tan x is sec x plus c. Okay. So that is the end of the sum. Any feedback? You understood this? Okay. Next problem, that is 6 sub question 1. Integration of 1 upon 1 plus cos x dx. Now this is a direct formula. 2 cos square x by 2, half angle, x becomes x by 2, half outside, sec square x by 2 dx, half integration of sec square x is tan x. But when I compare this with sec square x, formula of sec square x, who is x? Will you tell me? When you compare this with sec square x, who is x? X is x by 2. X is x by 2. Okay, so that's LAT, linear algebraic term. Dy dx of x by 2. Chain rule will come over here. Okay, so dy dx of x by 2 is going to be half. When you solve this, this is going to be half. This 2 and this 2 will get cancelled. Okay, so it will be tan x by 2 plus c. 6 sub question 2, you can solve it for self study. Okay, I'll go to 6 sub question 3. Integration of 1 upon 1 minus sin x dx. So there is, whenever there is 1 plus sign or 1 minus sign in the denominator, we have to rationalize 1 minus sin x, 1 plus sin x, and this is also 1 plus sin x. So 1 plus sin x into 1 minus sin square x. So 1 plus sin x into upon cos square x. 1 plus sin, 1 minus sin in the denominator, always rationalize. Now split and solve. Any doubts still here? So this is 1 upon cos square plus sin x upon cos square. 1 upon cos square is x square plus sin x upon cos x into cos x. So this is equal to sec square x plus tan x into sec x. Okay, so this is tan x and cos goes up, it becomes sec x. Individual integration because there is a plus sign. So tan x plus sec x plus c. Tan x plus sec x plus c. Done? You have any queries? Next one, 6 of question 4. Integration of 1 minus cos 2x upon 1 plus cos 2x. Now see guys, this is half angle formula. 2 sin square x, 2 cos square x. 2 got cancelled, this is tan square x. Now I don't know whether I've told you this or not, but then tan square and cot square, what do we do? There is no formula in integration for tan square and cot square. We have the formula for sec square and cosec square. So first convert this into fundamental identity. Sec square x minus 1 dx individual integration. So sec square x is tan x and 1 is x. Okay. Why individual integration? Because there is a minus sign in between. Only for plus minus you have to do individual integration. You are clear with this? Yes or no? Okay. Then question number 6, sub question 5, integration of 1 plus cos x dx, 2 cos square x by 2 dx. Okay, so root 2 will go outside and root of, split the roots because there is multiplication. I've used half angle formula 1 plus cos x. So 2x becomes x, so x will become x by 2. Root 2 cos x by 2. Now integration of cos is sine. So cos x by 2 will be sine x by 2, where x is x by 2, LAT, linear algebraic term. So this will be root 2 sine x by 2 upon half plus c. So this is 2 root 2 sine x by 2 plus c. I hope you are understanding. You have to take positive roots only. Integration take positive roots only. Definite integrals, we might think of positive or negative, but then integration, Indef, use positive roots only. Don't take plus minus. Okay, so that was question number 6, sub question 5. Let's go to sub question number 6, sub question 6. Integration of root of 1 plus sine 2x dx, half angle formula 1 plus sine 2x, cos x plus sine x the whole square. So this is integration of cos x plus sine x. Integration of cos is sine and integration of sine is minus cos. This is your answer. Towards the end, you can just multiply plus and minus and make it minus. Done? Question number 6, sub question 7. Integration of cos x root 1 plus cos 2x dx cos x 2 cos square x dx. Separate the root. Separation is possible because of multiplication. Cos x into cos x dx. Okay. Yeah. Next one. Next step. So this is root 2 of cos square x. Now, if you remember, whenever the problem is sine square and cos square, whenever the problem is sine square and cos square, we multiply and divide with 4. Do you recollect this? Yes or no? Sine square, cos square, multiply and divide with 2. 2 cos square x is 1 plus cos 2x. Now, individual integration. X plus sine 2x upon 2. Cos integration is sine along with chain rule. So when you compare this with cos x, who is x? X is 2x and 2x is LAT. Clear? 6 sub question 8, you can solve it for self study. But then prior to that, will you just tell me whether this is clear to you? Okay. 6 sub question 9, integration of cos x minus sin x, cos x plus sin x, 2 plus 2 sin 2x. So I'll take that 2 common, which is over here. I'll put it outside the integration sign because it's a constant. Cos x plus sin x, cos x minus sin x upon cos x plus sin x. 1 plus sin 2x dx. Okay, now 1 plus sin 2x, again I'll use half angle formula. That is cos x plus sin x the whole square. Now one of the term will get cancelled. Okay. Now we are left with a minus b into a plus b. That is a square minus b square. But then 2 if they're outside. Okay. Guys, can you tell me what is cos square x minus sin square x in half angle? Please tell me. Waiting for your answer. What is cos square x minus sin square x in half angle? It is cos 2x. Okay. So this is equal to 2 integration of cos 2x dx 2 into sin 2x upon 2. Down there is 2 because of the chain rule. So eventually this is going to be sin 2x plus c. Clear? Six, question number 10. Okay. 4 minus sin x upon cos square x plus 1 upon sin square x cos square x. Okay. Now what I'll do is I'll split. Okay, so this is 5 sin x. Sorry. Okay. So I'll split this. 4 upon cos square x minus 5 sin x upon cos square x. Now this one, I'll write it as sin square x plus cos square x upon sin square x cos square x dx. Okay. So this is 4 x square x minus 5 sin x upon cos x into cos x plus here also I'll split sin square x upon sin square x cos square x plus cos square x upon sin square x cos square. Here I'm splitting. Okay. So here sin square is getting cancelled, cos square is getting cancelled. This will be tan x into sec x. And here cos square goes up and sin square goes up. I hope you're understanding. So I'll just write it over here. 4 sec square x minus 5 tan x into sec x plus sec square x plus cosec square x. Don't have space. But I hope you're understanding this. Okay. Yeah. So integration of 4 sec square x minus 5 tan x into sec x plus sec square x plus cosec square x dx. Now this is individual integration. So the final answer I will not write, I'll just dictate. It will be 4 tan x minus 5 sec x plus tan x plus minus cot x. Cosec square x integration is minus cot x plus c. Okay. Yeah. Now if you look at question number 3, sub question 10, is it manageable? 3 sub question 10. Yes or no? It's the same thing, no? 1 upon sin square x cos square x, this part. So can you solve this on your own? Okay. Question number 3, sub question 12. This is also self-study. You will have to do individual integration over here. Individual integration. Fine. Okay. Let's go back to the question number 6, sub question 11. Integration of sin x plus cos x root of 1 plus sin 2x dx. Okay. So I'll just write this as cos x plus sin x. And down we have a formula. Cos x plus sin x d whole square. 1 plus sin 2x is cos x plus sin x the whole square. So cos x plus sin x upon square and the root gets cancelled. So this is 1 dx, which is equal to x plus c. Clear? You need any further help in this? Okay, let's go to question number 7. Integration of root of 1 plus sin x by 2 dx. So 1 plus sin x by 2 is cos x by 4 plus sin x by 4 the whole square. See now, 1 plus sin 2x formula is cos x plus sin x the whole square. So 1 plus sin x by 2 will be, what is half of x by 2? X by 2 divided by 2. X by 4. You got the point. Okay. Now root and square will get cancelled over here. So this is going to be cos x by 4 plus sin x by 4. Okay. So cos is sin upon dy dx of x by 4, which is 1 by 4. And sin is minus cos. Sin is minus cos upon dy dx of x by 4, which is 1 by 4 plus c. Then you can take this 4 up over here. Any doubts, any queries? Okay. Let's go to question number 10. Tan inverse of sin 2x upon 1 plus cos 2x. Tan inverse of 2 sin x cos x. Within the round bracket, I am just using half angle formula. 2 and 2 is getting cancelled. Cos square and cos is getting cancelled. So we are left with tan x. So integration of x raised to 1 dx. What is x raised to 1? X raised to 2 by 2. You have any doubts, you should ask. Okay, great. Question number 11. Cos inverse of 1 minus tan square x, 1 plus tan square x. Okay. So cos inverse of 1 minus tan square of x upon 1 plus tan square x is cos 2x. Do you know this formula? 1 minus tan square x upon 1 plus tan square x. It's cos 2x. So cos inverse and cos will get cancelled as per the rules of ITF. 2 will go outside, x raised to 1. So 2x square by 2, which is equal to x square plus c, which is equal to x square plus c. Yeah. Question number 12. Integration of cos inverse of sin x. So cos inverse of, first use complementary angle, cos pi by 2 minus x. Okay. So this and this will get cancelled. So we are left with pi by 2 minus x. So this is individual integration. Pi by 2 is a constant, so integration of pi by 2 is pi by 2 x minus x is x raised to 1. So x raised to 2 upon 2 plus c. Is this clear? Yes or no? You have any doubt in this? Okay. Let's solve question number 8. Let's solve question number 8. Sin raised to 6x plus cos raised to 6x upon sin square x cos square x. So this I'll just write sin square x the whole cube plus cos square x the whole cube upon sin square x cos square x. A cube plus b cube. So a plus b, a square, this is 4 minus ab plus b square upon sin square x cos square x. What is the value of this orange colored part? 1. Okay. So now you divide this, split this upon this upon this, and this upon this. This is turning out to be 1, so that's not really a problem. So I just split sin raised to 4x upon sin square x cos square x minus sin square x cos square x upon sin square x cos square x plus cos raised to 4x upon sin square x cos square x. Okay. So this is sin square upon cos square, which is tan square x minus 1. This is getting cancelled plus cos square x upon sin square x, which is cot square x. Now, whenever it is tan square and sec square, tan square and cot square, use fundamental identity. So I use fundamental identity of tan square, fundamental identity of cot square. Okay. Have I done something wrong? Okay. So this will be sec square plus cosec square minus 3. Okay, so this will be sec square plus cosec square minus 3. Now sec square is tan, cosec square is minus cot, and 3 is 3x. So it will be tan x minus cot x minus 3x. Individual integration. You want me to write that? Okay, question number 3, sub question 8 and 9. Question number 3, sub question 8 and 9. I'll just give you hints over here. Integration of sin x into sec square x. Get that sec square down. So that will be cosec square x. Okay. Sin x, cosec x into cosec x. Okay. So this will be tan x and this will be sec x. So tan x into sec x, which is sec x. Is this easy for you? Question number 3, sub question 7 also I will do. Cos 2x 2 sin square x upon cos square x. Now cos 2x is what? 2 sin square x minus 1 plus 2 sin square x upon cos square x. Okay, one second, I just wrote the wrong formula. Cos 2x is 1 minus 2 sin square x. Okay, sorry. So this and this is gone. So this will be 1 upon cos square, which is sec square. Correct? Which is going to be tan x plus c. 3 sub question 11. First we'll do 3 sub question 9. So multiply and divide with 2. Send this to outside. And what is 2 sin x cos x? What is 2 sin x cos x? Sin 2x, correct. And sin 2x is minus cos 2x upon 2. Okay. Sin that integration is minus cos upon dy dx of 2x. 2x has to be LAT, which is LAT. Okay. Yeah, I'll discuss one last problem. That is question number 3, sub question 11. In this problem, you further can multiply this 2 and this 2 because there is multiplication over here. You can make it 4 plus c also you have to mention. Question number 3, sub question 11. Integration of sec x upon sec x plus tan x. So 1 upon cos x, 1 upon cos x, sin x upon cos x. So convert everything into sin and cos. Okay. So simplify this further. 1 upon 1 plus sin x dx. How to solve this further? How to solve this further? How to solve this further? Yes, correct. Rationalize. 1 plus sin, 1 minus sin in the denominator. Rationalize. Good. Okay. So you can solve this further on your own. Fine. Thank you.